Welcome back to the deep dive. Today, we're diving deep, you guessed it, into the cardiovascular system.
The circulatory system.
Yeah, the circulatory system that keeps our blood pumping.
Yeah.
And if you like what you hear, remember to like and subscribe to the Deep Dive channel for more anatomy adventures.
Absolutely.
All right, let's get started. Have you ever thought about how the heart knows how much blood to send to every part of the body?
It is a remarkable system. The heart doesn't think in the way we do. It's more of a finely tuned machine,
Okay.
constantly adapting to the body's needs. The amount of blood pumped with each beat changes based on factors like your activity level,
Okay.
stress, and even the temperature outside.
Wow. So if I'm running to catch the bus, my heart's working harder than when I'm just relaxing.
Exactly. Your muscles need more oxygen when they're working hard.
Right.
So the heart pumps faster and harder to deliver that oxygen-rich blood.
That makes sense.
Hey.
And speaking of delivering blood, we got to talk about the vessels themselves.
Right.
Our sources mention the aorta, the largest blood vessel in the body.
Yeah.
I remember from anatomy class that it's like a major highway for blood carrying it away from the heart.
That's a great analogy.
Yeah, but why is that so important?
Well, the aorta has to withstand a tremendous amount of pressure with each heartbeat,
Oh, yeah.
which is why it's built with thick elastic walls.
I see.
But that also makes it susceptible to problems like aneurysms where the wall weakens and could potentially rupture.
Oh, wow.
So understanding its structure is crucial for diagnosing and treating these conditions.
Yeah, I never really thought about it that way. That's incredible how structure and function are so intimately related.
Absolutely.
Wow. And the aorta is just one part of this intricate network, right? We also have arteries, veins, those tiny capillaries.
Precisely. Each type of vessel plays a specific role.
Right.
Arteries are like the delivery trucks carrying oxygen-rich blood away from the heart.
Okay.
Veins, on the other hand, are the return route bringing deoxygenated blood back to the heart
Oh,
to be replenished.
I remember always getting arteries and veins mixed up. Is there an easy way to remember the difference?
Absolutely. Think A for arteries and A for away.
Got it.
Arteries carry blood away from the heart.
Got it. That's a good mnemonic. But there's that one artery that breaks the rules, right?
Yes.
The pulmonary artery. It carries deoxygenated blood,
Great.
which seems kind of counterintuitive.
You're right to point that out. The pulmonary artery is a crucial exception. It's part of the pulmonary circuit,
Okay.
responsible for taking deoxygenated blood from the heart to the lungs to pick up oxygen.
Like a detour to the lungs.
Exactly. It's like a pit stop for the blood to get a quick oxygen refill before heading back to the heart to be circulated throughout the body.
I see. So the blood gets oxygenated in the lungs, goes back to the heart, and then gets pumped out through the aorta to the rest of the body.
That's right.
What happens next?
Well, that's where things get even more fascinating. To understand the journey, we need to dive into the concept of systemic circulation.
Okay, systemic circulation.
Think of it as the highway system that delivers oxygen and nutrients to every single cell in your body.
Okay, systemic circulation. It sounds pretty important. Where do we begin?
Imagine the aorta branching out into smaller and smaller arteries, like a tree trunk splitting into branches and then twigs. These arteries carry oxygen-rich blood to every organ and tissue in your body.
This is a really efficient delivery system,
Yeah.
right? And what about those tiny capillaries we talked about earlier? Where do they fit into all of this?
Capillaries. Capillaries are the smallest blood vessels, so tiny that red blood cells have to squeeze through them single file.
Wow.
They're like the back roads connecting those major highways to individual houses. It's at the capillary level where the real magic happens. The exchange of oxygen nutrients and waste products between the blood and the body's cells.
So the capillaries are like the ultimate delivery service. That's pretty cool. What happens to the blood after it makes its deliveries?
Well, now it's time for the return trip. The capillaries converge into larger vessels called venules, which then merge into veins, carrying deoxygenated blood back towards the heart. This blood still has some oxygen, but it's also carrying carbon dioxide and other waste products picked up from the cells.
Oh, so it's like a recycling system. Cleaning up the waste and getting ready for a fresh batch of oxygen.
Precisely. And to ensure that the blood flows in the right direction, veins have special one-way valves.
Okay.
These valves prevent backflow, which is especially important in the legs where gravity is working against the upward flow.
Makes sense. It's amazing how the body has these mechanisms to keep things running smoothly. But sometimes things go wrong, right?
Unfortunately, yes.
Like with coronary artery disease, which we talked about earlier. Could you explain that a bit more?
Of course, coronary artery disease affects the blood vessels that supply the heart itself.
Oh, wow.
It's a serious condition where plaque, a buildup of cholesterol and other substances, narrows the arteries, restricting blood flow to the heart muscle. This can lead to chest pain or angina and even heart attacks.
So it's like the heart's own delivery system gets clogged up. What are some of the things that can cause this plaque buildup?
There are many risk factors, some controllable and some not.
Ugh.
High cholesterol, high blood pressure, smoking, diabetes, obesity, and a family history of heart disease all increase the risk.
So living a healthy lifestyle can make a big difference.
Absolutely. Eating a balanced diet, exercising regularly, maintaining a healthy weight, and not smoking are crucial for preventing or slowing the progression of coronary artery disease.
That's good advice for everyone. And early detection is key, right?
Yes,
Well,
regular checkups with your doctor can help identify any potential problems early on.
it's a good reminder that we have a lot of control over our own heart health. Now, going back to the anatomy, I remember struggling with some of the more complex terms in school. For instance, what exactly is an anastomosis?
An anastomosis is a natural connection between blood vessels.
Okay.
Think of it like a detour or a backup route for blood flow. They're especially important in places like the hand and the intestines, where alternative pathways are crucial for maintaining blood supply, even if one route is blocked.
That's fascinating. So it's like the body has built-in redundancy to keep the blood flowing.
Exactly. And sometimes surgeons even create artificial anastomoses to bypass blockages or reroute blood flow, which can be life-saving in certain conditions.
Wow, I'm learning so much. And speaking of complex terms, what about portal hypertension? I remember that being a tough one to grasp.
Portal hypertension is a condition where the blood pressure in the portal vein, which carries blood from the digestive organs to the liver, is too high.
So the portal vein is like a major traffic route for blood coming from the digestive system.
No.
But what causes this hypertension in the portal vein?
The most common cause is cirrhosis of the liver, where scar tissue blocks the blood flow through the liver.
Okay,
This backup of blood increases the pressure in the portal vein.
that makes sense. And I remember seeing some pretty disturbing images associated with portal hypertension, something called caput medusae. Is that related to this backup of blood?
Yes, it is. Caput medusa, or head of Medusa, refers to a network of dilated veins around the belly button.
Oh, wow.
They become engorged with blood due to the increased pressure in the portal system.
Okay.
It's a striking visual manifestation of severe portal hypertension.
It certainly sounds it. Okay, so we've covered a lot of ground from the basic anatomy of blood vessels to some complex conditions like coronary artery disease and portal hypertension. Is there anything else about the circulatory system that you think our listeners should know?
One thing I'd like to emphasize is that the circulatory system is incredibly dynamic and adaptable.
Oh, yeah.
It's constantly responding to changes in our body, whether it's adjusting blood flow during exercise or fighting off infections.
Right.
Understanding this dynamic nature is key to appreciating how the system works as a whole.
That's a great point. It's not just a static network of pipes. It's a living, breathing system. And speaking of living, we've been talking about the vessels themselves, but what about the blood that flows through them? What's so special about its composition?
Blood is fascinating. It's made up of plasma, the liquid part, and various cells, including red blood cells, white blood cells, and platelets. Each component has a vital role to play.
Right. Red blood cells carry oxygen. White blood cells are part of the immune system. What about platelets?
Platelets are essential for clotting. They rush to the site of an injury and form a plug to stop bleeding.
Oh, I see.
It's a remarkable process, and it highlights how even the smallest components of blood play a crucial role in our survival.
It truly is amazing how everything works together. So we've explored the anatomy of the cardiovascular system, delved into some common conditions, and even touched upon the composition of blood. What's the key takeaway for our listeners today?
I think the most important message is that understanding your cardiovascular system is essential for maintaining your overall health.
Right.
Knowing how it works, recognizing the risk factors for disease, and making healthy lifestyle choices can significantly impact your well-being.
Absolutely. Couldn't have said it better myself. And remember, this deep dive is just the beginning. There's a wealth of information available, and we encourage you to keep exploring.
Absolutely. The human body is a lifelong study, and there's always more to learn.
That's all the time we have for today's deep dive into the cardiovascular system. A huge thank you to our expert for sharing their knowledge and insights.
It was my pleasure.
And of course, a big thank you to our listeners for joining us on this anatomical adventure. Don't forget to check out kenhub.com for more in-depth resources on this topic and many others. Before we go, we'd like to leave you with a thought. We've talked about how the heart pumps blood throughout the body. But what triggers that first heartbeat in the womb, and how does the circulatory system develop before birth? Food for thought. Thank you for listening to The Deep Dive. Until next time, keep exploring.